Alright, in the first lecture of insertion of a node in AVL tree, we have mentioned that when we insert a node to the AVL tree, we have two cases. So the first case is rotation is not required, and the second case is rotation required. So when we have a rotation required, we have subcategories like this. So we have four conditions in this case: left-left condition, left-right condition, right-right condition, and right-left condition. Now here in this lecture, I'm going to combine all these conditions in one example to see the big picture of insertion of a node in an AVL tree. Now let's say we have numbers like this and we want to insert these numbers to an AVL tree. And our objective is to see all these four conditions over here. So let's get started to create an AVL tree based on these numbers. So we are going to insert these nodes to the AVL tree, and whenever we need a right rotation or left rotation, we are going to perform it. So the first element is 30. So when we are inserting 30 to AVL tree, in this case we don't have AVL tree, so this means that we are going to create an AVL tree and assign 30 as a root node. Now after assigning it as a root node, in this case we don't have any disbalanced over here, so that's why we are going to continue to the next node. Now the next node is 25. Now when we reach the 25, we are going to decide that if we are going to add this 25 as a left child or right child. Now we know that AVL tree is binary search tree, so this means that the nodes that are less than equal to the root node will be located at the left subtree. So this means that 25 will be added as a left child of 30 over here. Now after addition, we are checking that if this addition causes disbalance or not. Now in this case we see that we don't have any disbalance over here, so that's why we are going to continue to the next node. Now in the next element we have 35. So here again we are going to compare 35 with 30, and we see that it's greater than 30, so this means that it will be added as a right child over here. Now after addition, we are checking that if we have any disbalanced node over here or not. Now in this case we see that this is balanced tree, so this means that we don't need to do any rotation over here. So then we are going to continue to the next node. Now the next node is 20. Now to add 20 over here, first we are going to compare 20 with the 30. We see that it's less than 30. This means that we are going to continue to the left subtree. So in the left subtree we have 25. So 20 is less than 25, so this means that it's going to be added as a left child of 25. Now after addition, one more time, we are going to check if we have any disbalanced node over here. Now we see that 25 is not disbalanced and 30 is not disbalanced because the left subtree's height in case of 30 is 2 and the right subtree's height is 1, so the difference between them is 1. So this means that this is not disbalanced. Then we are going to continue to the next element. So the next element is 15. So to add this 15 to this AVL tree over here, first we are going to compare 15 with 30. So in this case we see that it's less than 30, we are going to compare it with 25. So it's less than 25, we are going to compare it with 20. So it's less than 20, so this means that it's going to be added as a left child of 20 over here. Now after addition, we are checking 20 if it is disbalanced or not. So it's obvious that it's not disbalanced, so we are going to continue to 25. Now in this case, the left subtree's height in case of 25 is 2 and the right subtree's height is 0. So this means that this node over here is disbalanced. Now after identifying the disbalanced node, the next step is we need to identify which condition is this. So to identify the condition, we are going to look for a path from this disbalanced node to its grandchild. Now in this case, the grandchild is 15, so the path to the 15 from 25 will be left and left, because in each step we are continuing to the left subtree. So this means that this is left-left condition. Now we know that in case of left-left condition, we are doing right rotation for this balanced node. Now in this case, this balanced node is 25, so this means that we are going to do right rotation for 25. Now if we do the right rotation for 25 in this case, our disbalanced node will become like this. 25 will come as a right child of its left child and everything will remain same. So in this case, if you check any node over here, you will see that this tree is balanced tree. Now let's continue to add next element. Now the next element is 5. Now to add 5 to this AVL tree over here, one more time we are going to compare it with 30. We see that it's less than 30. We are going to continue to the left subtree. So in the left subtree we have 20. So here again 5 is less than 20. So this means that we are going to continue to the left subtree. So in this case we see that in the left subtree we have 15. So here again 5 is less than 15. So this means that we are going to add 5 over here as a left child of 15. Now after addition over here, one more time we are going to check that if we have any disbalanced node over here. Now in this case, we can easily see that 30 over here is disbalanced because the left subtree's height is 3 and the right subtree's height is 1, and the difference between them is 2. So this means that in this case 30 is disbalanced node. Now here again, after finding the disbalanced node, we need to identify which condition is this. Now as we said before, to identify the condition we need to find a path from this balanced node to its grandchild. Now in this case we see that 30 has two grandchild, in this case 15 and 25. So we are going to take the one which's height is more. So in this case we can easily see that 15's height is 1, 25's height is 0. So this means that we are going to find a path from 30 to 15. Now in this case it's going to be left subtree, then the left subtree. So this means that this is left-left condition. Now we know that in case of left-left condition we are doing right rotation. So we are going to do right rotation for 30 over here. Now in this case, when we are doing right rotation, 30 will become the right child of its left child, and left child's right child will become the 30's left child. So in this case, the case will be like this. So here you can easily see that 30 comes down as a right child of the 20, and 20's right child becomes left child of 30 over here. So 25 becomes over here like this. Now after doing so, the next node that we are going to add is 10. So here again we are going to compare 10 with 20. In this case 20 is the root node. So this means that it's less than 20. We are going to continue to the left subtree. So in the left subtree we have 15. So one more time we are going to compare it. 15, we see that it's less than 15. So this means that we are going to continue to the left subtree. So in the left subtree we have 5. So 10 is greater than 5. So this means that it's going to be added as a right child of 5 over here. Now after addition, we are checking 5. 5 is balanced node, so we are continuing to the 15. So in this case, we see that for the left subtree's height in case of 15 is 2, and the right subtree's height is 0. So this means that 15 over here is disbalanced node. Now after finding the disbalanced node, the next step that we are going to do, we need to identify the condition. Now in this case, from 15 to its grandchild is going to be left and the right. So this means that this is left-right condition. And as the name implies, we know that in left-right condition, we are doing first left rotation for the left child of this balanced node, then we are doing right rotation for this balanced node. Now in this case, we are going to do left rotation for 5. So if we are doing a left rotation for 5, 5 will become left child of its right child. So in this case, after rotation is going to be like this. Now after doing left rotation, the next step is we are going to do right rotation for 15 over here. So whenever we are doing right rotation, in this case 15 will become the right child of its left child. So the rotation will be like this. Now after rotation, you can easily see that we have completed left-right condition as well. So here, after implementing left and right rotation, we have made our tree balanced. Now the next node that we are going to insert is 50. So in this case, whenever we are inserting 50, we are going to compare 50 with 20. So in this case, 50 is greater than 20. So this means that we are going to continue to the right child. So in the right child, we have 30. So we are comparing 30 with 50. We see that 50 is greater than 30. So we are going to compare the right child. So in the right child, we have 35. We are going to insert 50 as a right child of 35 over here. Now, after insertion, we are going to check that if we have any disbalance node over here or not. Now in this case, we see that we don't have any disbalance node. So this means that we are going to continue to the next node, which is 60. So whenever we are adding 60 over here, one more time, we are going to compare 60 with root node. So in this case, 60 is greater than 20. We are going to continue to the right subtree. So in this case, 60 is greater than 30. So we are going to continue to the right subtree. So in this case also 60 is greater than 35. We are going to continue to the right subtree. So in the right subtree at the end, we have 50 over here. So 60 is greater than 50. So this means that it's going to be added as a right child of 50 over here. Now after addition, we can easily see that 35 over here is disbalance node. Now after finding the disbalance node, we need to identify the condition. Now to identify the condition, we need to find a path from this disbalance node to its grandchild. Now the 35's grandchild is 60 and the path will be right and right. So this means that this is right-right condition. Now in case of right-right condition, we are just doing left rotation. So in this case, we are going to do left rotation for this disbalance node over here. So in our case, this balance node is 35. So we are going to do left rotation. So whenever we are doing the left rotation for a node, in this case, this node will become its right child's left child. So after rotation is going to be like this. Now here we have successfully implemented left rotation for right condition, and we have made our AVL tree balanced. Now let's continue to the next element. So the next element is 70. Now here again we are inserting 7 to this AVL tree. So here we are going to compare it with 20, then we are going to continue to the right subtree. So then one more time we are going to continue to right subtree. So in the right subtree we have 50. So 70 is greater than 50. So this means that we are going to continue to the right subtree. So in the right subtree we have 60. So 70 is greater than 60. So this means that it's going to be added as a right child of 60 over here. Now after addition we can easily see that 30 over here is this balanced node, because the left subtree's height is 1 and the right subtree's height is 3, and the difference between them is 2. So this means that 30 over here is this balanced node. Now in this case, after identifying the disbalanced node, we need to identify the condition. So here again we are going to find a path from this 30 to its grandchild, and we are going to take the child which is height is greater. Now in this case grandchild of 60's height is greater, so we are going to find a path from 30 to 60. Now in this case we are going to continue to right and right. So this means then here again we have right condition. So in this case we know that in case of right condition we are doing left rotation. Now if I do a left rotation for this case over here, I'm going to do left rotation for this balanced node. Now in this case this disbalanced node will become the left child of its right child, and the right child's left child will become the right child of this disbalanced node over here. Now in this case it's going to be like this. So as you can see, the right child of 30 was 50 becomes the parent node, and 50's left child becomes the right child of 30 over here. Now after doing left rotation we can easily see that this tree is balanced over here. Now at the end we have 65 over here, so we are going to insert 65 to this AVL tree over here. So here again we are going to compare it with root node, which is 20. So it's greater than root node. We are going to continue to the right subtree. So in the right subtree we have 50. So we are going to compare it with 50. We see that it's greater than 50. This means that we are going to continue to the right subtree. So here again we see that in the right subtree we have 60 and it's greater than 60. So this means that we are going to continue one more step to right subtree. Now at the end we have 70 over here. So this means that 65 is less than 70. It's going to be added as a left child of 70 over here. Now after adding this, we can easily see that 60 over here becomes disbalanced. So after finding the disbalanced node, we need to identify the condition. So in this case, it can be easily see that this is right-left condition, which is the last condition in our case over here. So after identifying the condition, we know that in case of right-left condition, we are performing right rotation for the right node of this balanced node, then we are performing left rotation for the node itself. So in this case, the right child of this disbalanced node is 70, so this means that we are going to perform right rotation for 70 over here. So for such cases, whenever we are implementing right rotation, the node becomes its left child's right child. So after rotation is going to be like this. Now after finishing right rotation, we are going to do left rotation for the node itself, for the disbalanced node. So in this case, disbalanced node is 60. So in this case, we are going to do left rotation for 60 over here. So whenever we do a left rotation for 60, it's going to become its right child's left child. So after doing left rotation, it will be like this. Now after doing so we have successfully inserted this 65 over here, and it caused this balanced node, and we have made it the balanced node. So after doing so, we can easily see that this tree over here confirms with the properties of AVL tree. Now with this, we have come to the end of this lecture. So in this lecture, I have inserted these elements to the AVL tree, and while inserting them, I have shown you 4 conditions that we have for insertion all together. So this means that whenever we are inserting a node to the AVL tree, we need to find the disbalanced node, then we need to check the condition, and based on that condition, we are going to perform left or right rotations. So hopefully everything is clear about insertion a node in an AVL tree. Now in the next lecture, we are going to implement this logic in practice. So see you in the next lecture.